Good day everyone, I am Jeffrey C. Concepcion, a researcher from Group 8 Engineering. I am here together with my group mates Mark Christopher Owen Balakyot, Michelle Andy Mendoza, Maxine Aymari S. Aplon. We are here to present our research entitled Improvised Copper Aluminum Solar Plates, an innovative alternative device to gather sun energy.
So for the abstract, all solar energy that reaches the Earth is referred to be a solar energy. 6 distinct setups will be used to assess the voltages available to solar energy at various times and locations. The results were put to the test using the t-test, and it was discovered that there was no significant difference between the three setups. The researchers needed the materials such as copper board, tining wire, cable wire, and sodium ferric chloride could be utilized as alternative solar plates. The outdoor setups have higher voltage than the indoor setups, according to the data collected. And the outside setups are more exposed to the sun energy, thus there is a lot of voltage. When the voltage comes from the number of plates, where time and location are exposed, solar plates makes a significant difference.
Introduction. The distance of the Earth from the Sun is about 149.1 million kilometers far. This causes most of the country on Earth to experience moderate to intense temperature due to the indirect exposure to the big star. As Philippines is located near at the equator with a distance of 898.21 miles of northern hemisphere, making the country experience an intense sun exposure. Due to the geological location, a lot of people, industries, and infrastructure, mostly in the urban areas, use it as an advantage. They utilize solar energy to run their appliances, machines, and other micro and macro electric powered equipment for sustainability. Due to this reason, people concluded of using and converting sunlight to mechanical energy make things functional and beneficial, also known as solar energy. However, despite of numerous numbers of solar power plants in the Philippines, most of the rural areas do not have solar facilities to support its people, especially those living in the countryside. To assess the problem about the proper use and gathering of solar energy, this study was conducted. The aim of the research was to provide an improvised solar plates that was economical with the use of renewable solar energy. This study generally aims to provide an improvised solar plates that is economical and helpful. Specifically, the main goal of this study is to first generate a solar plate using cheap and available materials in three setups. Setup 1 with 2 solar plates, setup 2 having 3 solar plates, and setup 3 which has 4 solar plates. Second, determine the voltages of the different setups of the improvised solar plate located in an open area and enclosed area at a given time of 9 a.m., 12 noon, and 3 p.m. And third, determine if there is any significant difference between the voltage of the solar plates placed indoor and outdoor when it comes to the location, number of plates, and the time when the plates are being exposed. This study is deemed beneficial to the community of Balayan as it provided knowledge on how to build your own improvised solar plates as well as determine the voltage it can give that possible be a reference in building a huge solar panel that could run home appliances. Since this study was conducted in the vicinity of Barangay Kaibunga, Pook, and Lokban, people living in these barangays can determine how to build an improvised solar plates that can be used to power their home appliances. The local community of Balayan will also benefit from the study as it can be used for further improvements of having an improvised thrifty solar panels in the whole vicinity of Balayan. Also, this study can be used as reference material and guide to future researchers to gain additional informations and improvements to the study. Parallel to this study primarily focused on determining if there is any significant difference between the number of solar plates and its voltage on the improvised solar plates. The study was conducted from 22nd of March to 30th of June 2021. The researchers set up the planned project by gathering the needed materials. After gathering, the solar plate was assembled and put on trials. Hypothesis testing was used as the statistical treatment of the study. This study was only limited on determining the voltage of the improvised solar plates. Other further experiments and data were not included.
Methodology. Procedure. Gathering of all the materials and equipment needed. The materials and equipment needed in the research experiment were 18 pieces of 6 cm by 2.5 cm copper board, 5 meters wire, 600 meters sodium ferric chloride, 10 meters thinning wire, rubber gloves, alcohol, cotton, permanent marker, iron solder, voltmeter, and box plastic container. All the materials and equipment needed in the experiment were put in a working table to be able to stay organized and well. All the needed materials were affordable and can easily find on electrical stores and even at home. Designing of the solar plate and the trial setup table. The 18 pieces, 6 cm by 2.5 cm copper boards were marked by permanent marker. Horizontal and vertical lines were drawn in the copper board to secure the area for thinning. Positive and negative signs were labeled as well. And for the trial setup table, it was done with several rows and columns where the gathered data will be put in. Etching of the copper board. Using the sodium ferric chloride solution, the designed solar plates were etched. It was done by soaking the sodium ferric chloride solution with the copper board. After soaking, you have to dry it using the cotton balls and wipe it with an alcohol to remove the permanent marker that secured the needed area for the solar plates. Thinning of the solar plates. When the copper boards were already etched, the next process was thinning. The researchers used a soldering iron and thinning wire to execute the procedure. When the soldering iron was hot and ready, they started thinning one part of the copper board, which was the positive side. Then, after all the positive areas were thinned, the strip wires were put on the end of the copper board where the positive and negative signs were located. This process was repeatedly done with the rest of the copper boards. Assembling of the solar plates and preparation of the trial setup table and data gathering. The table where all the gathered data was prepared together with the solar plates set up and the voltmeter. A voltmeter is a device used to measure the voltage in each setup. For the control group, the 3 setups were placed in the table and it was put in an open area at a given time of 9 a.m., 12 noon, and 3 p.m. The voltages of the 3 setups were observed and noted. And for the experimental group, the 3 setups were placed only indoor at the given time of 9 a.m., 12 noon, and 3 p.m., where the voltage will be observed, measured, and noted. The statistical treatment. In order to statistically test and gather data, one-way ANOVA test and paired t-tests were utilized. One-way ANOVA test was a type of inferential statistic used to determine whether there were any statistically significant difference between the means of 2 or more independent groups. and paired t-test is used to compare the means of two measurements taken from the same individual, object, or related units. The two statistical analysis tool were the basis to figure out if the researchers will accept or reject the hypothesis.
Results and discussion.
6 setups of solar plates were observed and tested to get the voltage in respect with the location and time they are exposed to the sun. 3 setups were tested indoor and another 3 setups outdoor. Setup 1 contained 2 solar plates, Setup 2 contained 3 solar plates, and Setup 3 contained 4 plates. The setup was exposed to the sun simultaneously and tested using voltmeter. The time when the solar plates were exposed and placed both outdoor and indoor are 9 a.m., 12 noon, and 3 p.m. Based on the data gathered from the solar plates placed outdoor, Setup 1 gathered 1.8 mV, 1.9 mV, and 1.7 mV respectively. Setup 2 gathered 3.2 mV, 3.4 mV, and 2.3 mV. Setup 3 gathered 4.1 mV, 4.7 mV, and 3.8 mV. The p-value of setups 1, 2, and 3 at the time 9 a.m., 12 noon, and 3 p.m. when they exposed to the sun are 0.02, 0.03, and 0.04. In terms of voltage of solar plates placed outdoor, since the p-value 0.56 is greater than the set level of significance 0.05 as well as the f-computed value 0.734, 226009, which was less than the f-critical value 4.0661051, means that there is a significant difference in the number of plates, the location it was placed, and the voltage of the solar plates.
And for the conclusion, based on the findings of the study, the following conclusions were derived. 1. Copper board, tining wire, and cable wire and sodium ferrichloride can be used as an alternative improvised solar plate. A piece of 6.5 inches by 2.5 inches improvised solar plate can hold up to 0.3 millivolts. In line with this, 2 pieces, 3 pieces, and 4 pieces of solar plates individually can hold 1.9 millivolts, 3.4 millivolts, and 4.7 millivolts respectively. Number 2, the voltages got from the 3 setups of the solar plates that was placed outdoor and observed from 3 different time of 9 a.m., 12 noon, and 3 p.m. got a higher value of voltage compared to the voltages of the plates that was placed indoor. When the voltages of the solar plates that was placed indoor, the following values obtained. Setup 1 that contained 2 solar plates have the voltages of 1.8 millivolts, 1.9 millivolts, and 1.7 millivolts respectively. While in setup 2 that contained 3 solar plates gathered 3.2 millivolts at 9 a.m., 3.4 millivolts at 12 noon, and 2.3 millivolts at 3 p.m. And in the last setup that have 3 solar plates, the voltages that obtained were 4.1 millivolts, 4.7 millivolts, and 3.8 millivolts with respect to the time it were exposed, while the data gathered from another 3 setups that placed indoor were followed in order based from the time when they were exposed to the sun were 1.4 millivolts, 1.6 millivolts, and 1.5 millivolts for setup 1, which has 2 solar plates, 2.6 millivolts, 3.1 millivolts, and 2.1 millivolts for the second setup that have 3 solar plates, and 3.4 millivolts, 4.2 millivolts, and 3.7 millivolts for the third setup that contain 4 solar plates. And lastly, there is no significant difference between the voltage of the solar plates in terms of the location where the plates were exposed and the time the plates are being exposed, since the p-values were less than the critical values. In contrast with this, there is a significant difference between the number of solar plates and the time it was exposed to the sun in a constant.
Recommendations. Based on the conclusions derived from the study, the following recommendations were given. First, improving the solar plates. The researchers may add some materials that will improve the solar plates. The materials that must be used are those that will help the solar plates to gain even more higher voltages and that will provide durability and quality. Second, create a solar plate that will benefit large number of users. The researchers may create a bigger version of solar plates that could be used by large number of users. This is a huge help to the people and the community in terms of having an economical alternative source of electricity. Third, evaluate the efficacy of solar plates. The researchers may suggest to the future researchers to evaluate the capability of the solar plates on how it could be useful and applicable for the community as well as a subject or improvement and innovation. And we are the Group 8 Engineering, and that would be all. Thank you.